Okay, so the previous problem we did in lesson 2.5, you were given the quadratic functions. These, you have to make them before and really what you're doing is you're finding the vertex. Okay?
Best way, I'll talk about this as we go along. Yep.
Now, his first one, all right there, Smiley? All right. Isn't exactly one that happens in real life, okay? But it gives you an idea of how we do the problem, okay? Because we approach these problems the same way. So find two numbers whose difference is 6 and whose product is a minimum. Give me two numbers that differ by 6. Give me two numbers that differ by 6. 5 and 6 and 12. What's the product?
3.
Did you just say 3? Oh. What's their product? 72. Give me another pair of numbers, but I need this smaller. 4 and 16.
Oh, wait, no. 3 and 9.
3 and 9. 27. Good. Smaller. Can you go smaller? Dana, they have a difference of 6.
1 and 7.
1 and 7. Multiply to get 7. Can you go smaller? 0 and 6. Can you go smaller? Yes. It's okay to say a negative number. -1 and 5. Don't write these down on here because you're going to. Okay, we'll stop there. Because you can see, guessing is not very efficient.
When we have a way to do it logically. Okay. Here's how we do it.
First of all, how many unknowns are there? What am I trying to find? How many numbers am I trying to find? Are you messing with me?
No, I'm serious. Because we're trying to find one number.
I think you're messing with my head.
Okay, so when we started, you guys have done problem solving like this before. What did we always call the first one? If we don't know what it is, what do we call it? Yes, X. What do I call the second one? Well, I got to use X. But I got to make sure this one is 6, has a difference of 6 from this one. How would you write that?
Plus 4 minus.
Right. You could write X plus 6 or X minus 6. Doesn't matter.
Those are two numbers that I don't know
They have a difference of 6.
I want to find
Their minimum product. Well, what do I do to find product? I multiply the two unknowns together. Let's multiply this through. What do I get? X squared minus 6x.
You just constructed the quadratic function. Okay?
In the last problem we did, this was given to you.
Well, it wasn't that one, but it was a different one. Okay? How do I find the minimum at this? The minimum. What point is the minimum called? The vertex. So I need to find the vertex.
By doing negative b over 2a. What's b? So it's negative negative 6. Divide 2 times. No, what's a? 1. And what does that give me?
Positive 6 3.
You just found
The first number.
the first one is 3. How do I find the second number?
Plug it in here and be 3 minus 6. So I'm ready to write my sentence. The numbers are 3 and 3 minus 6, which is negative 3, which makes sense.
Because what's the product of those two? Negative 9. You can't get lower than negative 9. Okay? Because if you try two negatives, when you multiply them, they become positive. Right?
So think of it almost like a graph, where this is the first number. This is the first number, and this is the product. What it does is if the first number is 0, the product is 0. Right? And then if it's 1, then the other number is negative 5, so it goes lower. If it's 2, the other number is negative 4, so it goes lower. If it's 3, the other number, the product, is negative 9,
It bottoms out.
as soon as you try 4, 4 times negative 2 is negative 8,
Starts to come back up.
so this is a graph of the situation.
That's the answer we want. Okay?
Let's try one more. Let's just do this page. And then can work on a few problems. We'll finish it on Thursday.
Okay, so we're building a rectangular fence along a lake, and we've got 800 meters of fencing. You don't need to fence along the lake. Okay? You need to find the dimensions of this rectangular area, the length and width, that will give you the maximum area.
So imagine we have a lake. We have a rectangular area, and this is 800 meters total.
Okay? Again, you could guess and check, but it's not very efficient.
Like, what if I said, okay, I'm going to use 100 meters fencing there. Don't write this down. Which means this must be 100. And this must be, because I'm only allowed 800 meters of fencing.
800.
No. I've already used 200.
600.
600.
So there's a possible answer.
And what's the area of this? 600 times 1,000.
Which gives us 60,000 meters. Okay? But the question is, are there different dimensions that will make the area bigger? Or rather, like I said, rather than guess and check, let's use algebra.
Let's call this the width x. Which means that this must also be x.
Here's where you got to think a little bit.
What's an expression for this length?
That's five,
X.
y,
No, you can't use two different variables. Otherwise, you won't be able to answer the question. Think of the total amount of fencing you have.
What do all three of these add up to? 800. Take away x, take away another x. So 800, take away the two widths.
That's an expression for the length. Now we're ready to construct
The quadratic function. So the maximum area, you can always write this, equals width times length, or length times width. Doesn't matter which. Thank you.
So we're going to do this.
Well, now we got to put it,
Before we can do the x vertex formula, we got to put it in proper form.
so I got to multiply it through, and I get and then all I'm going to do is rearrange it because we're used to seeing the x squared term first.
Okay, so I just flipped the two.
So now I'm ready to use my formula, because what do I want to find? I want to find the width at the maximum. Because if I find the width at the maximum, I can find the area by plugging the width into here. So what's B?
800,
So negative 800, divide 2 times negative 2.
$200,
200.
And what does that 200 represent? It represents the width at the maximum area.
So that means these two have to be 200. And how do I find the length?
Plug 200 into here and calculate. So the width, because we're asked to find the dimensions, or actually I should say a width of 200 meters and length of 800 minus 2 times 200, which gives me 400 meters. Will give the maximum area. So that is a fully completed solution.
Okay. And again, you could graph this situation.
Here we've got the width we're trying to find and the area. Well, if the width is 0, that means the area is going to be nothing. That just makes sense. And then as you increase the width, the area is going to increase, but it's going to reach a maximum.
And it's eventually going to come back down to 0 again. So it's a quadratic function. Okay.
Okay,